Okay, let's do a problem with counting possibilities. For summer 2013, this is problem 2 on your first section of homework, and it is exercise 32 in the book. It tells us that a stereo store is offering a special price on a complete set of components: your receiver, compact or CD player, speakers, and turntable. And you get to choose who you want, or what piece you want for the receiver, what piece you want for the CD, what piece for the speakers, and what piece for the turntable. And you can combine your selections for each of the 4 things to get any one of your possible combinations. So let's look at A. So in how many ways can one component of each type be selected? Now notice we do have these red values. That does mean these are randomized values, so your answers will be different than my answers. But the method will of course be the same. So let's do part A first. So the way I like to do this is I just start trying to think about it, and I say, okay, I need to choose a receiver and a CD player, speakers, and a turntable. And I say, how many options do I have for the receiver? I have 3 options for the receiver. Then I have 4 options for the CD players, 2 options for the speakers, and 4 options for the turntables. So if I want to know how many ways can one component of each type be selected, well, these are all my choices, and I'm just going to multiply. So this is our fundamental counting principle, that if we want to figure out the total number of possibilities, we just multiply the number of choices for each category. So 3 times 4 times 2 times 4 gives me 96. So those are the total number of possibilities of ways that I could build my sound system. For B, in how many ways can components be selected if both the receiver and the compact disc player have to be Sony? So again, I'm going to write out these 4 slots. Okay, but now how many choices do I have for the receiver? I only have 1 choice because I already know it has to be Sony. And how many choices do I have for the CD player? Again, I only have 1 choice because it has to be Sony. They didn't say anything about the speakers or the turntables, so we still have 2 and 4 choices. Okay, and so if we multiply here, 1 times 1 times 2 times 4, we get 8 possibilities. C, in how many ways can components be selected if none are going to be Sony? So let's look back up. To choose my receiver, how many choices do I have if I don't want a Sony? I would have the Kenwood or the Sherwood, which means I have 2 possibilities. Okay, for the CD player, if I don't want a Sony, I'm going to be left with 3 options. Okay, for the speakers, apparently at this store they don't have Sony speakers, so if I don't want a Sony, I still have 2 choices. And finally, for the turntable, if I don't want a Sony, I have 3 choices. And if I multiply all those possibilities, we figure out that there are 36 different ways I can build a sound system without including a Sony piece. D says, in how many ways can your selection be made if at least 1 Sony component is to be included? Well, the complement of at least 1 is none. So there are 96 total possibilities, and 36 for none Sony pieces. So that means 96 minus 36, or 60 possibilities for at least 1 Sony piece. So using the complement rule, we didn't subtract it from 1 because we weren't dealing with probabilities yet. We were just counting up possibilities. But if there's 96 total possibilities and 36 are for no stony pieces, then 60 possibilities must be for at least one stony piece. And finally, E. This will take the longest. So the first one says, what is the probability? So if they just randomly pick pieces, what's the probability that they contain at least one stony component? So the probability of at least one stony well, let's see, how many possibilities for at least one stony? It was 60 possibilities out of the total 96 possibilities. So 0.625. And then if we want the probability of exactly one stony component, we would need to do the number of possibilities with exactly one out of the 96 total possibilities. Now this is the most complicated part of the entire problem, is trying to figure out the number of possibilities with exactly one stony piece. Okay, so let's see if we can count those possibilities. Okay, so if I want a stony piece to go in the first spot, so the receiver, I only have one choice. Now when I go to pick my CDs, how many choices do I actually have? I'm not going to have 4 choices because we want exactly one stony piece. If I put a stony piece in the first slot, then I can't put a stony piece in the CD spot. So I actually only have 3 choices. So that's only going to be 3 choices. Now, there were no stony pieces in the speakers category, so that's still a 2. And then for the 4th piece, we still can't get a stony piece, so we are still at 3 possibilities. Okay. And if I multiply those together, then I get 18. But that's not the only way that I could get exactly one stony piece. Instead of getting getting one piece for the receivers, I could pick out a stony piece. Oops, deleted everything. I could pick out one piece for the CD, pick out the stony for the CD part, and then make sure everything else is not a stony. So for my first category, I would have 2 choices, because I can't include a stony. The 3rd category is still 2 choices, and the last category is 3 choices. So if I multiply those together, I get 12 possibilities. And let's see what else. I've chosen the stony in the first spot, the second spot. I can't put it in the 3rd spot because stony's not an option there. So let's try it in the last spot. So that would give me only 1 choice because I'm picking stony. And then let's see, we would have 2, 3, and 2. Remember, we can't include a stony in those other spots since we want exactly one stony piece. If I multiply those together, I get 12. So 18 plus 12 plus 12, since these are all possible ways to get what I want, gives me 42. So there are 42 ways to get exactly one stony piece in your sound system. So we have 42 out of 96, which gives me 0.4375.